Okay, so we're ready to create the deformers that we're going to use for the entire body of the character. And by deformers, I don't mean actually like the deformers as you would be thinking in Modo, like creating deformers here. I mean the items, the joints that we're going to use to deform the mesh of the character. And in this case, what we want is something very similar to what we see on screen here. These joints right there. We want basically the same. Plus, we need also joints per each twist locator that we created. So we need to have basically a new skeleton for the character that is going to deform the mesh, and this new skeleton is going to be constrained to each joint and twist locator that we have created, and it's going to be a completely new entity in our character modular structure here. So we're going to start by taking the guide rig. Let's unhide that, and since the guide rig already has everything we need, we can actually hide all the rest. To start with, we're going to start with that. Okay, so let's take our guide rig here and duplicate it. So now we have a new guide rig here, and let's rename it to group Deform Skeleton. Okay, and we're going to change its color to red, and we can hide the guide rig and we can start working with it. So the first thing I'm going to do is I'm going to select everything in here. Let's just double click to select the entire hierarchy, and we're going to change some of the display attributes on these guys to make it very clear these are our deformers, and it's not actually going to look like a skeleton, but it will behave as one. Normally what I would do in other applications is I would have everything here on a flat hierarchy. Everything would be flattened. We just basically see a list of locators, but Modo requires these to be in a hierarchy for it to be able to bind the mesh properly, because it traverses the hierarchy. So in this case, we're going to leave them as such, and we're just going to insert the twist locators we're going to use into the existing hierarchy. So, but I'm going to start by creating, let's go to the display tab, and we're going to make these guys, the wireframe color, we're going to make it into a red. Like so. And I'm going to get rid of the connecting lines. Well, maybe not for now. I'm going to leave them because I'm going to insert the other ones into the hierarchy. So let's rename these guys. We have to rename them. They're not going to be called J and T for joint. I'm going to rename them to DEF and get rid of the suffix. So DEF for me means it's a deform item. It deforms my mesh, and that's what I'm gonna call these guys. So I'm gonna pause the video right here, and I'm gonna come back when everything is renamed. I'll see you in a second. Okay, everything is renamed. As you can see, everything is called DEF, and the rest of the name is the same. Looks like I had a few problems with a couple of those over here that have the skeleton prefix. I missed those. I'm gonna get rid of that very quickly. This name comes from the skeleton tool. There you go. So now everything is okay. All right. So now what I need to do is let's bring back the rest of the character. I'm gonna collapse this. And I am going to, let's hide it for a second so we can clearly see the rest. I'm going to select the twist locators we created and also duplicate those. Okay, so let's select this guy, this guy. I'm just gonna go and select them manually, and then the ones on the legs, and finally the two small ones for the neck. There we go. Okay, and now that all that is selected, let's duplicate them. Now they're duplicated, and we're going to unparent them in place. All right, so they appear over here. Okay, I'm done renaming everything. As you can see, they're called DEF and the name of the joint that was part of the guide rig. So now what I need to do is let's unhide all of her character again, and just for now I'm gonna hide back our deformed skeleton layer. And now what I need is I need to take these guys, which are the twist locators, and also create duplicates of them. So let's do that. I'm going to select. There's two things we can do here. One is I can actually take them and duplicate them. The problem is these guys have constraints on them, so then I would have to go and delete the constraints on them one by one. Or I can just create locators and match them manually, which actually could be faster to do. The thing is I'll have to rename them later on, but let's try that for now. I'm going to create one locator, and we're going to set the drop action to match, and we drag and drop it onto our first twist item. And let's, since we're at it, let's change the display to spheres, because that's what we're going to use for these items. Something like that. We'll take care of the names later on. For now, I'm just going to worry about creating them and matching them. Okay, so we need another one here and another one over here. Now let's do the legs of the character. So all I'm doing is I keep on going, duplicating and dragging and dropping onto each location where I need one. Okay, now the other side. Cool. Now the arm. And lastly, 2 for the neck. Good. Now we can hide back our character. and just leave our twist joints right there. Now we're going to take all of these guys, and well, I could put them directly into the Deform Skeleton group locator, but since I'm just going to be inserting them in the hierarchy, then I'm going to leave them there for now. And let's see how we need to build this hierarchy. I'm going to show you. It's actually pretty simple. What I'm going to do is take this locator, okay, and I'm going to set my drop action to parent in place. Let's go find it here in the list. And I'm just going to drag and drop it onto the preceding one so it becomes its child. Okay? I'm going to do the same for him. I'm going to drag and drop it to this guy. And I'm going to take him directly, and I'm going to drag and drop it onto the one at the elbow. I didn't do this for him because there's two locators here that I can't make out very well. So I'm going to wait until I see which one is the one I need to drag to and drop onto, which is, I think, this one. So let's do that. Let's take him and drag and drop onto this guy, which has the same orientation. Okay. And we can actually start correcting the hierarchy by taking the one here at the elbow, and let's go find it. We're going to drag and drop it onto him. You will see some lines start to break. That's okay. It's because these guys don't have the same drawing properties as the ones we had before, so they're not displaying their connecting lines, but we don't have to worry about that right now. So now let's look at our hand. This locator over here is one for the hand, and this locator over here is for the wrist. And so we're going to take the one for the wrist and drag and drop it onto our last forearm twist joint. So as you can see, this hierarchy is already coming together. We have our clavicle, the clavicle end, which we're not going to actually need for our deformation rig, because there's no use of having two locators at the same place here, or two joints. So we can actually delete it immediately. And now we just have this guy. And if we walk down the hierarchy, if we pick walk, I can go from this guy to this guy to this guy to the elbow to the two twist joints to the start of the hand. And over here, it's the same case. We don't need the wrist locator. We just need the hand one. So I'm going to parent the hand directly to our last twist joint, and then let's go find the wrist locator and delete it. There we go. Whenever you see two joints or locators in the same spot, you won't need them. You just need one. Okay, so I'm gonna do it now for the leg so you can see how it's done again, and then I'll pause the video and do just the other side of the character and come back when it's done. I'll do the neck too at the same time so you can see what I'm doing. So we're gonna take this guy. Actually, we could start from right at the bottom. Well, we can start anywhere because we're using compensation anyway. So let's find our locator. In him, we're gonna drag and drop it over to this guy. Then this guy, we're gonna drag and drop it over to this guy. Then we take him and we drag and drop it onto our friend here. Then we take the one for the knee. Let's go find it and drag and drop it over here directly. Then we're going to take him. Let's find it and drag and drop it onto that guy. And as you can see, I'm always dragging and dropping to the one that precedes the one I have selected in the hierarchy. And finally, let's take the foot and drag and drop it over here. So let's see what that hierarchy looks like. If I double click, everything should be selected. Nothing should be left outside. That means we have a single hierarchy. So let's find that again. There it is. Our thigh, 3 twists, our calf or shin joint, 3 twists, and the rest of the rig. So that's exactly what we want to see everywhere. So I'm gonna pause the video and come back in a second to show you the rest of our deformation skeleton finished. Well, before I pause, I'm just gonna do the neck very quickly so that you can see it. So let's take, there's 2 locators here again. So we need to figure out which one we need, if it's the spine 07 or the neck. And it's definitely going to be the neck, the one we want to keep, because it's going to give us the rotations. Well, actually, we have these 2, which are our twists. Then we have the head joint right over here. So let's see which one I'm going to keep. I think I'll keep the neck. Let's connect the neck directly to spine 06, and let's get rid of spine 07, which would be right there. Okay, so we're going to take this guy and drag and drop it over to our neck joint. Then take this guy and drag and drop it onto him, and then take our head and drag and drop it onto him. Okay, so if we double click here, we should have everything, which is all this with the head, the jaw. Now there's one important thing to know before I go and pause this, and it's the way Modo performs the binding when you use a hierarchy like this is it will never assign any weights to the last item in a hierarchy. And that's why it's important that you have a last locator or joint that finish up the hierarchy, but that is not going to deform the mesh. So in this case, let's check it out with relation to our mesh. And what I'm talking about is, for example, for our head and jaw, like this is our head joint right here, okay? And there we are. And this is our jaw joint right here, okay? But we need these guys to be child of each of one of those joints to finish up the hierarchy, and they are not going to be deforming the mesh, and that's why I don't care that they're outside. They're just needed so that Modo can assign weight to their parents, which are the joints that I actually need to use. Okay, same case here for the hands. The actual joint for the last part of each finger, for the last joint in each finger, is right here, where you have the joint actually. But then we have these guys at the end that their only purpose here is to make sure that their parent receives or influences the mesh when we weight this, when we bind the mesh to our skeleton. Okay. And for the foot, the same thing. Here we have our last joint. Okay. So that's pretty much it. That's all I wanted to show you. So I'm going to continue. Oops, not him. I'm going to continue creating our hierarchies here for the rest of the character, and I'll be back in a second. Okay, I'm done. As you can see, I've done all my parenting. I can actually double click on the hip joint, that is the first one, and everything gets selected, so everything is a nice hierarchy. And I've also renamed all my twist joints to the name of wherever they belong. In this case, for example, this guy belongs to the thigh. Twist and number them, and they're also deformers or deforming joints. So I'm pretty much done with everything. All that's left is I'm going to just unify their display properties. So the first thing I'm going to do is here in the locator shapes, I'm going to remove the link because I really don't want to see that line. The lines between them are of no use to me because we're not going to be visualizing or using this as a normal skeleton in any way. So I just get rid of that. And the second thing I'm going to do is just to again set my colors so that the our new friends can also be red. Looks like these guys, oh yeah, they don't have draw options, so I need to add them first. And I think that might actually make them inherit the color immediately, because I already said it. No. let's do it then. Oh, looks like I set the wrong one. There you go. There we are. So this is our deformation skeleton. This is what we're going to be using to bind our mesh to. And now that it's done, all we need to do is constrain these guys to the actual joints that will be moving, so that they can follow that movement and deform the character in turn. And the reason why we didn't do it directly, it's because our character at this point is segmented in many different parts. We have arms and legs and all the stuff that all the work we've done to make this character modular prevents us from directly binding to those joints. And the second reason, it's also a lot easier to and safer to keep a totally separate layer in a rig that takes care of the deformations. That way, if there are changes we need to make to the rig, like adding joints or segments or more procedural locators that do other stuff, we're not really disturbing our deformations. And all we would need to do is, if we need more deformers, we can add them on this particular layer, tweak the binding, and continue working without really worrying about the rig. And if we hadn't done this, if you bind your mesh directly to the rig joints, then sometimes making changes to those joints or to the structure of that rig means you destroy your binding and your weighting. And then you have to resort to things like saving it to disk and then retrieving it somehow, things like those. So it's a lot safer to keep at all times anything that deforms the mesh in a totally separate layer of your rig, like we've done here. So we're done with this, and we can continue on attaching this skeleton to the main rig of our character. So let's do that in the next video. Alright, now that we're done with our deformation skeleton, it's time to constrain it to the actual joints that we're going to be using to move the character around. So this is what we're going to do. Let's unhide everything. And now we're going to hide a few things that we definitely don't need. So we don't need any of the controls. We can hide those in every rig. Basically, all we want to see is the main rig for each section of the character. So no IK, no controls, just something like that. We can hide all the rest. No IK, we need the joints, no controls, and we don't need those deformer locators. Okay, so this is all we want to see for the character. Actually, we have here, well, yeah, these are part of the, oh, here they are. FK and IK leg, we can hide those. Same for the other leg, FK and IK leg, we just leave the main. And same for the hands. Let's see where the hand controls are. In here, no arm IK, no hand FK. Can also hide the constraints. And let's do the same over here. Oops, that's the main rig. Okay. This is pretty much what we want to see. And now, what we're going to do is to constrain all of our locators to the main rig. So this is what we're going to do. We need to select each locator, each deformation joint, and its corresponding main joint, and constrain them together using a dynamic constraint. So, well, dynamic parenting, actually. This is what we're going to do. So let's make sure we're in setup mode and compensation is on. And we can start, for example, actually we can try to follow more or less the layout that we have here in the items list, so that we don't skip anything. So we're going to start with the hip. So we select the hip deformation joint, and we select the actual hip joint, and we say add parent, and you will notice that you get a dynamic parent for our deformation locator. So let's do that for each one of these. And actually turning compensation off should be no problem, because, oh well, in this case it looks like it was. So let's just do that without with compensation on. There we go. And now this guy is going to be parent located to this guy. Let's see where we are. Here we are, spine 0, 2. And then this guy to this guy. This guy to this guy. And this guy to this guy. Okay. Spine 0, 6. Then we have the neck, which is going to be parent constraint over here. Then we have the first neck twist, the second one. Then we get to the head, which has this joint, the head end, that goes with this other joint, the jaw, which uses this joint over here, and the jaw end with this joint. So far so good. We're done with this hierarchy. Let's go back and do the legs, and then we're gonna take care of the arms. So this guy is right here. This is the thigh, so we're gonna parent constrain it to the thigh bone. Then we have the first twist, then the second twist, the third twist, then we have our calf or shin deformer with its corresponding bone. Then we have the twist ones, and basically you just have to keep doing this. We have the foot, the toes, and the toes end, which is a little bit too big, so we cannot see the There we go. We cannot see the joint underneath. Good. We're done with that leg. We're gonna do the other leg. So this is all you have to do, is just keep adding the dynamic parents for each one of our joints here, our deformation joints. And they're still going to be in a hierarchy, as you can see, which means that Modo can traverse the hierarchy when we do the binding and do its job. But their transforms are going to be coming from the joints themselves. All right, we're done with torso, neck, head, and legs. Let's just do the arms. So we're going to start with the clavicle, which uses this joint. Then the upper arm, which uses this one. Then we have the first twist joint, second twist joint, and the forearm. Dynamic parenting can be sometimes a little bit quirky, and that's why I'm leaving compensation on. Ideally, I would use a constraint that is not dynamic, but there is no parent constraint in Modo. So another way of doing this would be to use position, rotation, and scale constraints. But then we have to do this 3 times per joint, and that would definitely be a little bit too much for what we're doing. So dynamic parenting should do fine. Adding a parent constraint using 3 different constraints should be scriptable, but that's a little bit out of the scope of this of this class. So we're just going to keep going with dynamic parenting. So this guy goes to the hand. Let's see, I think this is our hand joint. Yeah, this is the one. The big one is the wrist, which we're not using. So we're just going to go directly for the hand. And then we have to do our fingers. And the last one goes over there. We got the pinky next. We should have actually the index finger. The hierarchy is not in the right order, but that should not make any difference. It's just sometimes I just like to keep things consistent. There we go. Since we're almost done with this side of the character, with its hand, as you can see, the bulk of the work for the hands is basically the same. I'm gonna pause the video right here and just finish the hand, or actually I'll let you just watch the end of the hand for the character in case you're curious. And then I'll just pause the video and do the other arm for our character, and I'll come back when it's done. The only thing that I'm going to do before that is our deformation joints for the hands are a little bit too big. So let's select them all with the exception of the hand joint, and let's make them smaller. Maybe like so. There we go. That's a little bit better. Okay, I'm gonna take care of the other arm. It's just the clavicle, the arm, and the hand that we did so far. And I'll be right back as soon as this is done. Okay, I'm done. I've assigned each and every joint in the deformer rig its own dynamic parent constraint. So if we leave setup mode, everything should be fine. And well, now it's time to test it and see how we did. So I'm gonna unhide everything that we hid, all the controls and parts of the rig. So we obviously don't need all of it, but just in case, so we don't miss anything. There you go. And let's try moving some things around and see how our deformation skeleton works. It seems to be following quite nicely. We are not using IK for the arms at this moment. We're using FK, so let's try FK. Yep. The twists are working also fine. So looks like everything is working properly. You should have arrived to the same result. If you see something that is not moving, you can also grab the main control for the whole character and move it around, and nothing should be left behind, as you can see. So that's good. And we're pretty much done. This is all we needed to do. And we're ready to bind our mesh to our deformation skeleton. So let's keep working on that on the next video. Okay, we're ready to bind our character mesh onto our deformers that we have over here. So let's start by displaying the character mesh, which we have here in geometry. And right now we're going to get the cut res version, which is not what we need. So let's expand this, and we're going to hide the cut res and display the high res. And there we go. There it is. We really don't need all the meshes that we see there. We are only going to work with the main body mesh. So let's hide the rest and just leave the body mesh displayed. And let's bind our mesh. So binding is basically the process of attaching our mesh over to a hierarchy of locators or joints so that it becomes deformed by them. And it's an automated process for certain things that happen that could be done manually but would be very painful to do so. I'm going to show you what that is. in a second. Let's go to our lists tab here with the mesh we have selected. And if you expand the weight maps section, you'll see that at this moment there's nothing in there. And if we go to our Deformers tab, we have our normalizing folders for the spine and neck. And that's basically it, and some weight containers. So how does binding work? Well, all you have to do, it's actually a very simple process, is you go into setup mode, you select your mesh, and then you select the topmost joint or locator in the hierarchy that they're going to use to deform that character. So let's control select that, and you click on the bind button. And if everything was selected properly, you'll see this dialog, this bind dialog pop up with some options to determine how the binding is going to happen. So you have different binding types or methods, and you can read more about the differences about on all these methods in the online documentation. For now, I'm going to stick to using the heat method, which is actually the one that gives the best results in terms of how the character or the mesh is going to be deforming by default. This can be changed later on, of course. But it does have a set of particular requirements that the mesh must meet in order to be able to use this binding method. And the first thing is your mesh must be an enclosed volume. It must have no holes or gaps of any kind. Also, you must not have any mesh problems at the component level, such as floating vertices, single vertices, double edges, double polygons, stuff like that. And finally, all the joints that are going to be deforming the mesh must be inside of it. They all must be contained in the mesh. So that's what heat binding does. So let's click on OK. And we have no problems. Otherwise, Modo would have told us that it found some problem and the binding was not successful. In our case, it seems to have worked. If you ever run into a mesh that seems to have problems using heat binding, you can go to geometry and use the mesh cleanup tool to try to get rid of any problems. If for some reason your mesh cannot use heat binding, let's say that it's a character that was modeled in pieces and it doesn't form an enclosed volume or anything like that, you can use this smooth binding methods. The default weights that those methods generate are not as great as the heat method, but as I said, that can be worked out later on. So if you check what happened in our lists tab, you will see that we now have a bunch of weight maps listed over there, and we have one weight map per deformer in the hierarchy that we used to deform the mesh. So each one of these deformers has an associated weight map, and these weight maps determine which vertices are going to be deformed by these joints. And if we go to our deformer tab, we have a new normalizing folder over here. When I select it, you see all this colored display on the viewport, and this is basically telling us which areas of the character were assigned to each deformer or locator. So as you can see, this guy is probably influencing this blue part over here, and so on and so forth. Now I can open up or expand this folder and just select one by one, and I can walk through them, and I can see in red which parts of the model are going to be influenced by each one of these guys. And this is going to probably require some work on our part to get better deformations. We're going to do that in the next following steps. For now, you can just check which deformers are influencing which parts of the mesh. You can continue going through them. There's some areas of the model that of course are going to need some work. And it's important to note that the weights you see when you select one of these deformers are unnormalized weights. What that means is, let's take the head joint for example. This area over here that we see in red is the influence of this transform influence only. It's not being normalized against other transforms, like for example the jaw. So all we see is full red means it's 100% influence, and then as the red diminishes, it means the mesh is being influenced less and less by this particular deformer. If we select both together, then we have the influence of both joints displayed. So what's important about this is that when you start changing the areas of influence of each joint, we're going to do that later by doing something called weight painting. Those weights that you paint are the unnormalized weights. And we have this normalizing folder where all these transform influences are stored. That means that I could have, say, this vertex right here being influenced 100% by the head joint, but also 100% by the jaw joint. And obviously, in a normalized situation, you cannot have a vertex whose weights exceed 100%. So what's going to happen is, post influence, this normalizing folder is going to go through the vertices in the mesh and determine the actual weight for that vertex. So for example, in this case, since this vertex is going to report two weights from two different weight maps, both at 100%, the normalized weight for each is going to be 50%, so that they add up to 100. So that's important to know, because when you are visualizing one single weight map or influence, if this guy was 100%, you would see it full red. But that doesn't mean that the actual influence of this transform influence at the end is going to be that 100%. It's still going to be normalized against other influences in the area, or the ones that affect this vertex. So you have to keep that in mind when you are visualizing weight values directly in the viewport, that you are you're looking at the non-normalized values. And we're going to see some of that later on as we start to change the weights on our mesh. For now, all I wanted to do is walk you through the process of binding your mesh to the deformers that we have created, and seeing what that does. As you can see, it's just creating a normalizing folder, a bunch of transform influences that are attached to weight maps that were created on the mesh. These weight maps already have certain weight values applied to them, and obviously these transform influences are using the joints or locators that we use to bind to as the locator to use as a transform for the influence. And that's basically it. That's all I wanted to show to you in this video. So our mesh is actually bound right now. We can see that by going, for example, to our controls. Let's transform some of these to see what's going on. So as you can see, the leg now follows our joints right there, and yeah, it seems we have good deformations in our mesh. There's still some problems though, as you might have noticed when I moved the thigh control. The torso of the character is deforming, which is something we definitely don't want. So these are things that we need to correct, and that's going to be part of the process of weight painting and weight adjusting all over our mesh, which is what we're going to be doing next. So I hope you get a better understanding of what binding does, and what to look at when you start to examine your characters. And let's now look at how we can solve some of these problems that you will be seeing all over your mesh. So let's do that in the next video.